Hi everybody, in this video we're going to cover section 4.1, the Cartesian coordinate system. In this lesson we are going to cover the following points. First, we are going to graph and label ordered pairs of real numbers as points on a plane. Second, we are going to find ordered pairs of real numbers that satisfy a particular equation. And thirdly, we are going to locate points on a given graph of a line. Okay. This is going to be our foray into variables with two equations. And here is an example of a variable with two equations. It has one variable y, which is going to be equal to 6 times another variable, which we will call x, plus 3. So this is actually a linear equation in two variables. Suppose we let x be equal to 2. Well then, y will be equal to 15. To see that, what we will do is we will substitute 2 in for x. So we are going to replace x with 2, and then we'll have 6 times 2 plus 3. This would be equal to 12 plus 3, which would be equal to 15, which is why we have y is equal to 15. However, we can express this solution as an ordered pair, where the first coordinate corresponds to x, which is 2, and the second coordinate corresponds to the y value, which is 15. And since this is called an ordered pair, this obviously implies that the order matters in this particular construct. For example, or specifically, note that that the first value will always be the x value, and the second value will always be the y value. And also note that the ordered pair of 2, 15 is not the same as the ordered pair of 15, 2. A few other things about this equation with two variables. The first variable is called the independent variable. The first variable x is called the independent variable, or of course the first coordinate. And the main reason why it's called the independent variable, because x can take on any value that we wanted to, or more precisely, any value in its domain. Y is called the dependent variable because the value of y depends upon what we choose for the value of x. So while the value of x doesn't depend on anything, the value of y is determined solely by the value that we put in for x. So we say that the ordered pair 2, 15 is a solution to this equation because when x is equal to 2 and y is equal to 15, the equation is true. We'll get 15 over here and we'll get 15 over here. And any ordered pair that makes this equation true is called a solution to this equation. And as you might be able to notice, there are an infinite number of ordered pairs that are solutions to this particular equation. And if you actually plotted every single ordered pair, you would get a straight line. Now this is what we call the Cartesian plane. The Cartesian plane has a number of components. The first component is the horizontal axis. We tend to call this the x-axis. Why? Because this is the values we use to plot the x value for any coordinate. The next axis is called the y-axis, and it's called the y-axis because we use this axis to plot any of the y values for the coordinate at hand. And we have an origin. The origin is where the two axes intersect. The coordinates of that is 0, 0. So when we plot points using ordered pairs, we always start at the origin. And finally, the Cartesian plane is broken down into 4 coordinates. The first coordinate we call coordinate 1. And in this coordinate, both the x values and the y values will always be positive. The second coordinate we call coordinate 2. And in this coordinate, the x values will be negative because we're going in the negative direction, but the y values will still be positive. Keeping with our thinking here, coordinate 3 is over here, and here both the x values and the y values will be negative. And then finally for coordinate 4, the x values are positive, but the y values are negative. Okay, when we plot points on the coordinate plane, we tend to start at the origin and then we move either left or right depending upon the number, and then to get to the first coordinate, and then we go either up or down on the y-axis to find the second coordinate. And this is pretty much how this works. If we wanted to plot the coordinate 2, 3, we would start at the origin. We would go 2 units, 1, 2, over here. Okay, that gets us to our x value second, and then we would go 1, 2, 3 up to get to 3, and this would be the plot of 2, 3. If we wanted to plot negative 2, 3, we would start at the origin. We would move 2 units to the left, because that's the negative direction. We would move 2 units in the negative direction, which would be left, 1, 2, and then we would move 3 units up for the B point, 1, 2, 3, and that would give our plot right there for B. For C, I had to move around the origin thing here. For C, x is equal to negative 8, so we're going to go in the negative x direction, which is left, 1, 2, 3, 4, 5, 6, 7, 8. And then since the y coordinate is negative 5, we are going to go in the negative y direction, which by the way is down 5 units. 1, 2, 3, 4, 5, and that will put us here, and that would be the point for C. And then finally, for D, we would go, since it's 2, negative 3, we would go in the positive x direction by 2. 1, 2, that's to the right. But now to the negative y direction, which is down, by 3. 1, 2, 3, which would be this point right here. And there you go. So that is how we plot ordered pairs on the Cartesian plane. And one of the things I want you to notice is that there is a one-to-one correspondence to the points on the plane and the ordered pairs of real numbers. That means every different point on the plane will correspond to a different ordered pair. This one will be different, this one would be different, and so forth. Okay, for our first example, we want to graph this set of ordered pairs. And to do that, what we are going to do is we are going to follow these solutions, this strategy. We're going to start at the origin. We're going to move left or right for the x-coordinate. If the coordinate is negative, we're going to go left. If the coordinate is positive, we're going to go right. Then we're going to move up or down for the y-coordinate. Again, if the coordinate is negative, we're going to go down. If the coordinate is positive, we are going to go up. So let's get started with the first one, which is the point, the ordered pair negative 2, 1. Okay, we're going to start off at the origin. It's a negative number for x, for the x-coordinate, so we're going to go in the left direction. 1, 2, that puts me here. And then I'm going to go down 1. No, correction. The y-coordinate is positive, so I'm going to go up 1, and this is our point for A. Okay, awesome. Next is B, negative 1, negative 4. Since it is negative, we are going to go left in the negative direction for the x. Since the y is negative 4, or negative, we are now going to go down for the negative y value. 1, 2, negative 1, negative 2, negative 3, negative 4, and that is the point for B. Okay, for C, the x-coordinate is 0, which means we don't go anywhere. We stay right here where the origin is. The y-coordinate is 2, so we're going to go up 1. We're going to positive 2, so we're going to go up 2 units. 1, 2, and this right here is C. For D, we have 1, 3, so that's going to be 1 unit to the right for the positive 1 in the x direction, for the x-coordinate. And then we're going to go up 3 units for the y-coordinate, since that's a positive 3. 1, 2, 3, and this right here would be D. And then finally, for E, we have the ordered pair 2, negative 3. So for the positive 2 in the on the x-coordinate, we go right 2 units, 1, 2. But now we have a negative 3 in the y in the y-coordinates. So that means we have to go down 3. 1, 2, 3, and this right here is E. And that is our first example. Okay, this is example 2. For this one, what we want to do is we want to write down the ordered pairs for each coordinate. So this, and we have 4 coordinates. We have A, B, C, D, and O, which happens to be the origin. So how do we handle this? Well, let's take a look at, let's take a look at A. We're going to start at the origin. Now to get to A, we would go in the positive x direction 1, 2 units. So we're going to have a 2 for our x coordinate. And then in the y direction, we're going to go 1, 2, 3, 4 units. And that would be the ordered pair that represents A. For B, we are also going to go in the positive x direction because it's over here. 1, 2, 3, 4. We are going to go 4 units. But now to get down to B, we have to go in the negative direction. 1, 2, 3, 4. So since we went down for that one, that would be negative 4, and that would be the coordinates for B. For C, this time, we have to go in the negative x direction. 1, 2. We have to go basically 2 units in the negative x direction, so the x coordinate will be negative 2. And then for the y coordinate, we're going to go down 1, 2, 3. So that's the negative y direction, so we're going to put a negative 3 for that one. Let's see if I'm right. Lo and behold, I'm actually right. And then for D, we are going to go negative 1, negative 2, negative 3, negative 4 in the x direction. And then we are going to go 1, 2, positive 1, positive 2 in the y direction. So that's the ordered pair for D. I did that one right. And now notice what we have for O. O, we start at the origin, which is 0, 0. We don't go anywhere. We stay here. We move 0 units in the x direction, and we move 0 units in the y direction. So for the coordinates for the origin will always be 0, 0. Okay, so those are the 2 of the types of the problems that you will see on your homework. The third one is to determine whether ordered pairs satisfy a particular equation. So here's our equation. It is y equals 3x minus 2. Now this is the x coordinate, and this is the y coordinate. So what we want to do is we want to substitute the x coordinate into our equation and see if we get y. So let's go ahead and do that. We're going to substitute 0 in for x. If we do that, we're going to have y is equal to 3 times 0 minus 2. Well, 3 times 0, and that's just 0, minus 2. And that means that y is equal to minus 2. We have y is equal to minus 2. We have y is equal to minus 2. So this coordinate, this ordered pair makes this equation true. So this does satisfy the equation. Let's take a look at this one. This is 2/3, 0. So once again, we're going to let x be equal to 2/3. This is our x value. This is our y value. We're going to let x equal 2/3. And we're going to see if y is equal to 0. All right, well, let's go ahead and do the substitution. We're going to replace x with 2/3, and that means we're going to have y is equal to 3 times 2/3 minus 2. Let's have to include the entire equation. There's a couple ways to do this. We can realize that this 3 cancels out that 3. Another thing that we can do is realize that we can multiply the 3 by times 2, and that will give us 6/3 minus 2. Well, 6/3 is nothing more than 2. So that's 6 over 3, which is 2, minus 2, which will give us 0. So it indeed checks out, and that means that this ordered pair makes this equation true and is a solution to that particular equation. Okay, and then last we have for this example is we want to determine if this ordered pair right here is a solution to this equation. So we're going to let x equals to 2. and we're going to see if y is equal to 5. All right, let's find out. We're going to substitute 2 in here for x, and that means we're going to have y is equal to 3 times 2 minus 2. Okay, well, 3 times 2 is 6, minus 2, and that's equal to 4. That means we have y is equal to 4. Okay, y is not equal to 5 in this particular case. As a consequence, this is not a solution to the equation. So if you actually saw this in Hawks, you would actually go ahead and I believe would say false, but we'll actually walk through that real quick to see what it looks like. And here is the answers for you there. Well, actually, that's a mistake. I'm glad I caught that now. I can change that for lecture. This should say 5. I obviously did not update that from the last copy and paste. Okay. And again, once again, this ordered pair does not satisfy the equation. And that would be the answer to that particular problem. Okay, here is the next set of problems that you would have to look at. Here, we have one part of the ordered pair, and we need to figure out the y value that makes this equation true. Again, to read the problem, we have determine the missing coordinate in each ordered pairs so that it will satisfy the equation. So we want to find the value, we want to find the y coordinate which will satisfy this particular equation. So how do we do that? What we want to do is we want to, since this is x and this is y, we want to substitute 0 in for x and solve for y. So we're going to replace x with 0. That will give us 2 times 0 plus 3y is equal to 12. Okay, well, 2 times 0 is 0. That means we have 3y is equal to 12. We divide both sides by 3, and that means that y is equal to 4. So the value of 4 in for y will make this ordered pair satisfy the equation. So our answer will be 0, 4. And again, it is worked out for you here as well. Now notice that since x is 0, this also happens to be a point that sits on the y-axis. So this is actually sitting on the y-axis. As a consequence, we call this the y-intercept. All right, the next, and we'll talk about that when we talk about linear equations of two variables. Same problem. We're given x. We want to find that value of y that makes this equation true. So we do the exact same thing. We substitute 3 in for x. That will give us 2 times 3 plus 3y is equal to 12. All right, well, 2 times 3 is 6. That gives us 6 plus 3y is equal to 12. We can subtract 6 from both sides. Minus 6. This will allow us to get the term with the y in it isolated by itself. This would cancel. We would have 3y is equal to 6. Then we can divide. Now we have to get rid of this coefficient. We can do that by dividing both sides by 3. And then we would have y is equal to 6 divided by 3, which happens to be equal to 2. So if x is equal to 3, then the value of y equals 2 will satisfy the equation. And this is worked out here. Notice we've got 2 just as well. And again, the ordered pair 3, 2 will satisfy the equation. Okay, our last problem is this, or last part of this problem is this. Determine the missing coordinate in this ordered pair that will satisfy the equation. Now this time we are given y, and y happens to be equal to 0. So now we want to substitute in for y and solve for x. So we're going to let y be equal to 0. We put that in for that one, and we will have 3, no, I'm sorry, that's not 3, that's a 2. 2x plus 3 times 0 is equal to 12. Okay, well 3 times 0 is 0, so we have 2x is equal to 12. We can divide both sides by 2. And we will have that x is equal to 6. Okay, and that basically means that the ordered pair 6, 0 will satisfy is a solution. A solution to this particular equation. And of course, it's worked out again for you here. And once again, it says that 6, 0, the ordered pair 6, 0 will satisfy the equation. And actually, notice here, this is when y is equal to 0. So this point is actually on the x-axis. So we tend to call that the x-intercept, which once again tends to come in handy when trying to evaluate or analyze linear equations. And this, oh no, I have one more. I didn't realize that. Okay, and then I believe this is the last one for this set. Once again, we have that y is equal to negative 2. We need to figure out what x is. So we're going to let y equals negative 2. And we're going to solve for x. And if we do, we will have 2x plus 3 times negative 2 is equal to 12. All right, well, 3 times negative 2 is negative 6. We can add 6 to both sides to get the constant terms on the other side of the equation. And when we do, these cancel. We have 2x. 12 plus 6 is 18. And then divide both sides by 2. And we have that x is equal to 9. So it turns out in this case, the ordered pair 9, negative 2 is a solution. And that is what is worked out for you here. Okay, our last problem is this. You'll be given a table, and you will be asked to complete the table so that each ordered pair will satisfy this particular equation. And you're either going to be given an x value or a y value. If you're given an x value, you need to determine the y value. And if you're given a y value, you need to determine the x value. So this is how this is how this can work. Here we have x is equal to 0, so we want to substitute x into this equation. That will give us y is equal to 1 minus 2 times 0, which by the way is equal to 1. So y is equal to 1, and our ordered pair is going to be 0, 1. Okay, I'll get to the second one in just a second. Here we have x is equal to 1/2. Okay, we substitute 1/2 in for x. We will get y is equal to 1 minus 2 times 1/2. 2 times 1/2 is just simply 1. So that's going to be 1 minus 1, which is equal to 0. That means y must be equal to 0, and then our ordered pair is going to be 1/2, 0. And then for this one, we're going to have y is equal to, we're going to substitute 5 in for x. So we'll have y is equal to 1 minus 2 times 5, which is equal to 1 minus 10, which is equal to negative 9. So here y is equal to negative 9. And the a corresponding ordered pair will be, well, x is 5, y is negative 9. And now let's deal with this one. For this one, we have that y is equal to 3, and we don't know what x is. So we're going to have 3 for y is equal to 1 minus 2x. Okay, I had to bring this outside to deal with this. So again, let me rewrite that. 3 is equal to 1 minus 2x. One of the things that we can do is subtract 1 from both sides to get all the terms without the variables on one side, or all the constant terms on one side, and all the variable terms are on the other side. So we'll do minus 1 here, minus 1 here. We will add vertically. Here we will have 3 minus 1, which is 2. That's going to be equal to 1 minus 1, which is 0. They cancel, and we have left with negative 2x. We can divide both sides by negative 2, negative 2, negative 2, and we will have over here negative 1. These will cancel, and we have x. So we have x is equal to negative 1, and our ordered pair will be negative 1, 3. So that is what our table looks like. It's done slightly different in Hawks, but we will cover that in just a moment. Oh, and there it all is. I hope I did it right. Let me see. Oh, I have a typo. This should be 5, -9. Okay, so how does this look in Hawks? Well, just give me a second and I will show you. Okay, here I have Hawks up, and I'm going to go into practice. I have it set at pre-certified, and here is start. I'm going to just go through a few of them just so you get a flavor for how this works. Okay, so here I need to plot the two following points on the graph. I have to plot 0, -5, and then -6, -1. Okay, so for the first one, and we need to do this in order. For the first one, what I'm going to do is I'm going to start the origin, and since x is 0, I don't go anywhere in the x direction, but I need to go down 5 in the y direction. 1, 2, 3, 4, 5. And then -5, there's a dead giveaway. So I'm going to put my point there for A. Now for B, I want to go -6 in the x direction. 1, 2, 3, 4, 5. That helps. 6. And then 1 in the -1 in the y direction, which is basically down 1. And that would be B right there. And that's how you would actually do that particular type of problem. And yeah, I did it right. Okay. The next problem you're going to have is they're going to give you some points, and then you actually have to identify the coordinates. So here's A. Notice that to get to A, we have to go in the x direction 1 unit. So that's +1. And then we have to go in the y direction -5 units to get to A. So that would be -5. Okay, for the B coordinate, we would need to go in the x direction -5 units right here to get right under it. So that would be -5 for the B. And then, of course, all we have to do is go in the positive y direction 1 unit, and we are at the B. -5, +1. And hopefully that is correct. Okay, awesome. Okay, well, we've done that before. Of course, then you have to do the exact same thing with 3 points. And now we come to these particular types of problems where you're asked to asked to find that value of y that makes this equation true. Okay, so here I have my OneNote up, and we have 4x plus 2y is equal to 2. And we have the ordered pair 2 and something else. Okay, so we're going to let x equal to 2. That will give us 8 plus 2y. 4 times 2 is 8, is equal to 2. I can subtract 8 from both sides. -8, -8. These cancel. I will have 2y is equal to -6. And that y, divide both sides by 2. And I will have that y is equal to -3. So this answer should be -3. So that is pretty much, yay! And that's pretty much how you would do that one. And then this is a similar type of problem. So you can see how to answer that one, as is that. And now here are the table problems that I'm talking about. So here, they gave you, here we have in the equation, it happens to be y is equal to -2x plus 1. Okay. For the first one, we have that x is equal to -2. So we want to substitute -2 in for x, and that means we'll have y is equal to -2, -2 for x, so it's -2 times -2. Plus 1. Well, -2 times -2 is just +4, plus 1, and that is equal to 5. So in this case, y will be equal to 5. For the next problem, we have that y is equal to 1. So we want to substitute the 1 in for the y. And if we do, we will have 1 is equal to -2x plus 1. Now we want to get the variables on the terms with the variables on one side and the terms with the constants on the other side. So we want to get we want to get this one over there, and we can do that by subtracting 1 from both sides of the equation. And if we do, we have 0. We have 0 here as well. And that means that 0 will be equal to negative 2x. Okay, well, if we have that 0, so let me clean this up a bit. So when we solve this, we have 0 is equal to negative 2x. And of course, now you can see that the answer should be 0, but to bring this home, you can divide both sides by 2, or by negative 2, and we have that 0 is equal to x. So this should be 0. And let's see if I'm right. Yay me, I'm actually correct. Okay, so the next type of problems are these. Here we have considered the equations for the following ordered pairs: negative 2 comma y and 1 comma, or sorry, x comma 1. And they want us to plot the resulting set of ordered pairs using our answers from step 1. Well, what were our answers from step 1? I don't remember. Oh, here they are. They're right here. Okay, so this is what they want you to do. What they're asking you here is to drag a dot at the origin to plot one of the ordered pairs on the graph, and then grab the other dot at the origin to graph the other ordered pair. So the first ordered pair was negative 2, 5. So what we want to do is we want to grab this dot here. We want to move it down negative 2 directions in the x-axis, and then positive 5 in the y-axis, which would put it, not there, which would put it there. And then the next one is 0, 1. So we don't need to move it in any direction in the x-axis, but we need to move it up 1 in the y-axis. And there we are. Those are our 2 points. We can submit our answer, and we are right. And I believe those are the types of problems that you will be dealing with. This is, again, another table problem. We've seen that one. This is the last set of problems that you will have. Here we have considered the following equation. In this case, it is x minus 2y is equal to 4. All right, and we have the order pair 2 comma negative 1, and we want to determine if this ordered pair satisfies the equation. So what we can do is we can set x equal to 2, set y equal to 1, set y equal to negative 1. So this is, remember, this is x, this is y, and see if this is a true statement. So we replace 2 with x. We replace negative 1 with y. And hopefully that will be equal to 4. Let's go ahead and simplify. 2 times negative 1 is negative 2. So this is going to be 2 minus negative 2. Well, subtraction by a negative number is the same thing as addition. We can just change the signs and add. And that will give us 2 plus 2, which is indeed equal to 4. So we can come over here and click yes. Okay? And we can submit our answer, and lo and behold, we are right. Now, those are the types of problems that you will find. Again, there's the same type of problem right there in both practice and also in certification. And yes, you might need to deal with a fraction or two. And that is pretty much, no, that is all I have for this particular lesson. I hope you find it useful. If you have any questions, please feel free to contact me. And this is Bob Boyle, signing off.